Now the 15th question. In an equilateral triangle ABC, D is a point on side BC such that BD equal to 1/3 of BC. Prove that 9AD square equal to 7AB square. That is a question. That means here we have an equilateral triangle. Okay, let it be side of each side of this equilateral triangle AB, BC and AC equal to AB equal to BC equal to AC equal to A units. Okay, and what is another one given? It is given that D is a point on side BC. So I am going to mark D is a point on side BC such that BD equal to 1/3 of BC. So it is less than, we have to mark the point D less than half of BD, that is 1/3 of BC. Okay, so I am going to mark that point D on line segment AB, that side BC, let it be D. Okay, and what we have to prove? 9AD square. That means we have to join, in order to get the side AD, we have to join AD. Okay, 9AD square is equal to 7AB square. AB means in place of AB you can represent any of the side, because since it is an equilateral triangle, AB equal to BC equal to AC. Idea is clear, children? Okay, and we have taken each side of the equilateral triangle as A unit. BC equal to A unit, AC equal to A, and also that AB equal to A units. Okay, now we can solve this problem. Here we need a very important construction, and that is draw another line segment from the vertex A. That means we are drawing the perpendicular AE towards BC. Okay, so let AE is the perpendicular to BC. Being it is perpendicular, I am marking this angle as 90 degree. That angle also 90 degree. Okay, so here that is a construction. That means we need AE perpendicular to BC. Okay, see children, here we should consider this triangle ADE, then only we will have that term AD square comes in our result. Okay, since we have drawn AE perpendicular to BC, means this ADE is a right triangle. Okay, so I am going to apply this Pythagoras theorem upon this right triangle ADE. Okay, so consider right triangle AED, this triangle. Okay, this triangle. Okay, so by Pythagoras theorem, what is it? AD square is equal to AE square plus DE square. This is the hypotenuse, side opposite to 90 degree, and sum of the squares of other two sides. Okay, see children, here we have a result in terms of AD square, and we also need this AD square in LHS of our required proof. Okay, that means we have to replace its RHS by suitable substitution. That is clear, children, how we started? Okay, it's very important problem. See here, what is AE? By construction, AE is the altitude of this equilateral triangle. Isn't it? So we know that in an equilateral triangle, median is equal to the altitude. Altitude and median will coincide only in equilateral triangle. Here the given triangle is equilateral triangle. Okay, so that means AE equal to the median. AE equal to median, as well as this is the altitude of the triangle ABC. Okay, so which means since AE is the median, implies E is the midpoint of BC. Isn't it? E is the midpoint of BC means, or you can write BE equal to EC. See children? Or can you express this BE in terms of BC? Because we need the answer in place of this, there should come one of the side of the triangle ABC. either AB or BC or AC, because it's an equilateral triangle, all are the same. Okay, so since we are working on this side BC, okay, so we are representing this BE in terms of the side BC. Okay, that is what I am going to do now. And since E is the midpoint, okay, so we can write BE in terms of BC. Okay, that means half of BC, isn't it? The whole length and its half part is BE, another half is EC. Being E is the midpoint. So, BE equal to half of BC. Point is clear? Okay. See, in the right triangle AED which we considered, okay, we have to represent, we can represent or substitute this DE. Okay, from this figure, children, what is DE? From this figure, this portion, okay, this DE, can we write this DE is equal to, if you subtract this BD from the whole length BE, okay, that means that will give you BE minus BD, isn't it? See children, BE minus BD equal to DE, because we need to substitute for this DE and also AE. Okay, so here we can write this BE minus BD as DE. Okay, so what is our aim, children? We should get this RHS part in terms of side AB or BC or AC, that doesn't matter. Here we will get an answer in terms of BC. Okay, and see children, so I am going to substitute here BE, we already got that is in terms of BC, that is half of BC. So I am going to substitute BE as half of BC, that is BC by 2. Okay, and see children, BC, can you write this as A by 2? Since AC, AB, BC all are A, we have taken this side as A. So this is equal to A by 2. BE can be written as A by 2. Side half of BC by 2. And what is BD? BD is given as, see children, BD is 1/3 of BC. Okay, it is given here, given that BD equal to 1/3 of BC. 1/3 of BC. BC is a side, so you can write 1/3 into A. We have taken that BC as A, so, or you can write this as A by 3. That means here BD is 1/3 of A or A by 3. This is the length of BD, and BE is exactly A by 2, half of BC. Okay, so we are going to substitute here BD, the value as A by 3. It is clear, children? Okay, so we will get this DE in one term by cross multiplication. Okay, 3 into A, 3A, minus 2 times A, 2A, divided by 2 3s are 6. So 3A minus 2A is A by 6. That is DE equal to A by 6. So we can substitute here A by 6. That means we got DE in terms of side. A is side of the equilateral triangle. Now how can we substitute for AE? AE is not needed here in the required proof. See, what from the figure, what is AE? By construction, it is altitude of an equilateral triangle. By formula, what is that? Okay, we know that for equilateral triangle, altitude equal to root 3 by 2 into side. Side is A. If you know this formula, you can easily get this required proof without much steps. Okay, you can make the proof will make you simple if you know all these simple tips. Okay, so I am going to substitute here AE, that is the altitude, and its value is root 3 by 2 into A. Okay, so finally we got the substitution for both AE and DE as root 3 by 2 A, this is AE, so whole square. Okay, plus DE as A by 6. A by 6. So when you square this, root 3 A become in the numerator. So root 3 square is 3 A square divided by 4. 2 square is 4. A by B whole square is A square by B square. Numerator as well as denominator should be squared. So then only this will be correct. Okay, so 3A square by 4 plus here what we have A by 6 square, DE square. So A square by 36. 6 square is 36. Idea is clear, children? Then how can we simplify this? Here see the denominators, different unlike terms. But here 36 is a multiple of 4. So if you multiply both the numerator and denominator of the first term with which number? In order to make it like term, that is the denominator same. If you multiply 4 with 9, 36. So I am going to multiply this first term with 9. Okay, here the denominator also with 9. Okay, so in the next step, you will get 9 3s are 27 A square divided by 36. 9 4s are 36 plus A square by 36. See how this comes is clear, children? So 36 is new denominator. So this is a like fraction. By adding the numerator, by keeping the denominator same, that is the way we can add the like fractions. Okay, so 27A square plus 1A square, 28A square divided by 36. See the coefficient 28 and 36, which is a common multiple. Highest common multiple is 4. Okay, so 4 in 28 7 times, and here comes 9. That means here you will get 7A square divided by 9. What is in the LHS? That is AD square. Now we have AD square equal to 9A square by 9. What we need to prove? 9AD square. So how that can be? Children, if you take 9 cross multiplication to LHS denominator, from the denominator into LHS, so 9AD square equal to 7A square. What is A? A can be replaced with AB or BC or AC, being it is an equilateral triangle. So in order to get the required answer, I am going to substitute here A as AB. So A square is AB square. So you will get 9AD square equal to 7AB square. This is the answer. Now the 16th question. In an equilateral triangle, prove that 3 times the square of one side is equal to 4 times the square of one of its altitude. Question is clear. That means an equilateral triangle, whatever the triangle, it has 3 altitudes. And in particular, in this equilateral triangle, we have to prove that 3 times the square of one side equal to 4 times the square of its altitude, one of its altitude. Okay, so I have drawn a equilateral triangle ABC. Okay, and here in terms of altitude, we should get answer in terms of altitude. So we can draw an altitude from vertex A to the opposite side BC, being it is altitude 90 degrees. So let it be AD. So let AD is the altitude, okay, from A to side BC. Okay, and here equilateral triangle, right? AB equal to BC equal to, since ABC is an equilateral triangle, we have AB equal to BC equal to AC. Let it be A. Okay, actually what we need to prove, children, that is 3 times we have to prove that, okay, 3 times square of one side, AB square or AC square or BC square, doesn't matter. that is equal to 4 times square of 1 of its altitude, AD square. 4 times AD. This is what we need to prove. Okay, this you should write from the question. It is not given directly. Okay, so for that, since we have drawn AD, okay, we have AD by construction, AD perpendicular to BC. That means now this big triangle ABC divided into two right triangles. So I am going to consider one of them, that is in right triangle ADB, in right triangle ADB by Pythagoras theorem. Okay, by Pythagoras theorem. Okay, that is AB square of the hypotenuse. This is the hypotenuse opposite to the 90 degree, equal to AD square and BD square. AD square plus BD square. Here square of one side, square of the altitude, but we need substitution for BD because in the required proof that BD is not needed. It is clear, children, how the next step can be started. Okay, that means here DB from the figure. What is BD, children? BD is nothing but half of BC. Why? Because we know that in an equilateral triangle, altitude equal to median in an equilateral triangle. Okay, and we have taken this, all sides are equal to A, the unit A. So this is equal to half of BC. BD equal to half of BC. D is the midpoint. Okay, which means BD equal to DC. So exact half of BC is BD. Okay, so you can write BD as half of BC, or BC is A, so A by 2. Okay, now we have the substitution for BD. Okay, so I am going to make that substitution over this equation number 1. AB square, no change. AD square, we should get this in terms of AD square. Okay, and for BD, in the next step you can write A by 2 whole square. Isn't it? Okay, so I am going to substitute here precisely this A in terms of AB, because all the three sides are equal, right? So I am going to make that change by keeping AD square in that RHS itself. I am taking this A by 2 whole square into LHS. Okay, that means AB square is there in LHS. So minus A by 2. A by 2 I am substituting here A for AB by 2 whole square. Okay, equal to AD square. Okay, so here you will get AB square minus AB square by 4, 2 square is 4, equal to AD square. Now the cross multiplication, 4AB square, 4AB square minus AB square by 4 equal to AD square. What is, children? 4AB square minus AB square is 3AB square. That is, from this you can write 3AB square equal to divided by 4 equal to AD square. Okay, in the next step we can take this 4 to RHS. So 3 times AB square. I am taking 4 to RHS, so 4 times AD square. Okay, what we need, children? Here, what is this AB? The square of one side of this equilateral triangle. So 3 times the square of one side of the equilateral triangle. We have proved that this is equal to 4 times the square of its altitude, one of its altitude. AD is altitude, 4 times AD square. This is the 16th question. Now we are solving the last question of this exercise 6.5, that is the 17th question. Here we have to tick the correct options. We are given 4 options for this last question. Okay, that means in triangle ABC, the 3 measurements, the sides are given. Okay, then we have to find angle B, and we have the options 120, 60 degree, 90 degree and 45 degree. Okay, among these four options, you can easily get that answer, okay, by using the converse of Pythagoras theorem, because that is the only angle familiar with us. Okay, what is by converse of Pythagoras theorem? Okay, if the square of one side is equal to sum of the squares of other two sides, okay, the angle opposite to that longest side will be 90 degree. That is the converse of Pythagoras theorem. Okay, so that means we are going to get the square of each side and we are adding any one of these two, and that will be equal to another side, the third side. By converse of Pythagoras theorem, you can easily mark 90 degree. Let us check. Okay, see, in this question, AB is given as 6 root 3. So, its square, AB square equal to 6 root 3 whole square. That is 6 square is 36 and root 3 square is 3. So, which means 36 into 3, that is 18,108 centimeter. Okay, this is AB square. Okay, then AC square is equal to 12 square and that is 144 centimeter square. And BC is equal to, here it is given as 6 centimeter. So, BC square will be 36 centimeter square. Okay, so we have now all the three sides and in its square form. Let us check. AB 108 and here comes 144 and 36. So, the longest side square is 144. Okay, and that is equal to, that is AC square equal to 144 and the remaining two sides, let there find their sum, that is 108 plus 36, this is equal to 144. So, which means what we got now, here we got AC square equal to, here the sum of this BC square, okay, plus AB square. Okay, that means AC square equal to sum of BC square plus AB square. See, if you can draw like this, this will be the something we got, that is AB and BC. B is a common vertex. Okay, this will be 90 degree because the sum of the squares of these two sides, we have seen that the square of the third side, see here AC. Okay, so definitely you can mark here as 90 degree by converse of Pythagoras theorem. Okay, so here angle B equal to 90 degree. It is clear, children? So this is all about 6.5. Okay, I think all the problems from this exercise is clear to you. So thank you, children. Thank you for watching and supporting my channel. Thank you all.